Hello and welcome. Today we'll be looking at Introduction to Data Analytics and a brief history to how data has evolved. So by way of introduction, we say that data analytics is the process of examining, cleaning, transforming, and modeling data to discover useful information, draw conclusions, and support decision making. What does this mean? It means that data analytics involves getting data, analyzing this data, cleaning this data, and extracting actionable insights from this data. If the data that you have analyzed cannot tell a story, does not have any value, does not have any actionable insights, it means that you have not analyzed anything. You have not analyzed any data. Now, data analytics plays a crucial role in modern businesses, healthcare, science, and virtually every other field that generates data. The core goal is to uncover patterns and insights that drive informed actions or decisions. Now, we're going to look into a brief history of data analytics, how data evolved from the ancient times, from the early times to the present day. We say that in the early beginnings, data collection and data analysis trace back to ancient times when early societies recorded data for agricultural, astronomical, and administrative purposes. Early examples include the Babylonian clay tablets, the Egyptian hieroglyphs, and documenting, which was used actually to document agricultural yields and celestial activities. Now, some of the contributions of the ancient civilizations include contributions in data analytics, in analyzing data, includes in Egypt, we saw them use data for administrative purposes, including census and data records. In Greece, data was used in developing early forms of statistical thinking, with philosophers like Aristotle analyzing social and natural phenomena. In Rome, data was used in implementing data collection systems for public administration and military logistics. We move forward to the Middle Ages, where we saw some advancements in statistical methods. Statistics is equally a part of data, or a tool that is used in analyzing data. So in the Middle Ages, we saw slow progress in data analysis, but the Renaissance sparkled renewed interest and advancements in scientific and mathematical thinking. Some of the key contributors and the process of analyzing data in the Middle Ages includes Fibonacci, who introduced the Fibonacci sequence, which helped in applications in various fields, including finance and biology. We talk about John Grant, who is often called the father of demography. He analyzed mortality data in London, laying the groundwork for statistical analysis in public health. We move forward to the 17th and the 18th centuries. In these centuries, we saw a systematic approach to data analysis. We talk about John Napier, who invented logarithm and revolutionization of mathematical calculations. We talk about John Grant, again, who published natural and political observations made upon the bills of mortality, one of the first works to apply statistical methods to demographic data. Also in the 17th and the 18th century, we see Laplace and Thomas, who these ones formalized the probability theory known as the Bayes theorem, which was introduced in the 1970s and helped in providing a mathematical framework for updating probabilities based on new evidences. Talk about Frederick and Legendre, who developed the method of least squares, which is crucial for regression analysis. We talk about the 19th century, where we see a transition from theoretical developments to practical applications. Here we see the work of Florence Nightingale, who pioneered the visual representation of data using statistical graphics to advocate for healthcare reforms in the British Army. We see again Charles Babbage, who designed the difference between normal engines that we talk about and then the analytical engines, that the early computers or the early mechanical computers used. We see the Royal Statistical Society that was founded to provide a platform for the dissemination and advancement of statistical knowledge. All these things, or all these groups, are key contributors to the advancement of data analysis in their time. Fast forward to the early 20th century, where we see rapid advancement in data analysis. First of those that contributed to this is Ronald Fisher, who introduced maximum likelihood estimation and developed analysis of variance known as ANOVA. This is a very vital tool that is used in analysis, especially when it has to do with statistics. It is a fundamental tool in statistical analysis. We talk about William Cecily, who was a student at the time. He developed the T-distribution, which is crucial for small sample statistical inference. Moving forward to the 2000s to 2010, that is when we started hearing some advancements, major advancements in data analytics, and we call this era the big data or advanced analytics era. And here we saw the advent of electronic computers and the digital revolution. The explosion of this digital data, along with advancements in computing power, led to the emergence of big data. Technologies like Hadoop and cloud computing allowed organizations to process massive data sheets. Instead of storing data in bits here and there, you were able to store massive data, in your computer systems. Analytics evolved to include machine learning, data mining, and predictive modeling. Now, the proliferation of personal computers and user-friendly softwares also came along during this era. In this season, we saw such softwares like statistical software packages, which included SPSS, people that are into statistics. Especially, remember I said earlier that statistics is equally a part of data analysis. There is a part of analytics known as statistical analysis, and when you get to statistical analysis, you will have to use statistical tools to run those analyses. Now, statistical software such as SPSS and SAS were introduced into the data analysis system. We talk about relational databases and SQL. Some of us may be conversant with this. This has allowed for efficient storage, retrieval, and manipulation of large data sets. Again, the early machine learning algorithms, were introduced during this 2000s, during this era, and they included the decision trees, the neural networks, and the clustering technologies that laid the groundwork for more sophisticated models that we have today. Now, fast forward to our present day, from 2010 to the present day that we are in right now. Data has really evolved, and now it encompasses a wide spectrum, including real-time analytics, artificial intelligence, and deep learning. Tools like Python, R, Power BI, and Tableau have made analytics more accessible. The focus has shifted from data-driven cultures to data democratization and self-service analytics. All right. Yeah. Now, equally in this 21st century, data keeps evolving. Okay? Data analysis keeps evolving. Earlier, we said something about AI and machine learning. Hardly will you talk about data and not bring in AI. Data analytics, data science, data engineering, and the rest of that. These calls for the knowledge of deep machine learning, which is achieved by remarkable successes in tasks such as image recognition, natural language processing, and recommendation systems. All these things came about by the advancement in data, which brought about AI and machine learning systems. Also, we see a real-time processing and streaming data. This was equally made possible by the advancement in data. And this system enables applications such as fraud detection, predictive maintenance, and personalized marketing. We talk about Internet of Things. Here, we see an expanded scope of data analysis with connected devices generating continuous streams of data. Again, we talk about the privacy and ethics system. Some civilized organizations or civilized countries, they have laid down rules and regulations on accessing data. So all these things came about because of the advancement of data, and more so in our present day. All right. So in conclusion, we say that data analytics has evolved from simple statistical tools to complex AI-powered systems that drive innovation and efficiency. As data continues to grow exponentially, analytics will remain central to the shaping of the future across all sectors. Data is the new oil, as they say. Data analytics has evolved from the days of counting stones, using stones to keep or store information, to abacus, to the days of big systems, and now we have neural networks, we have AI. All these things came about because data has evolved. Right, as we continue, has evolved. Thank you.